Hello everyone. In this session we discuss about local search algorithms and optimization problems. What is an optimization problem? Optimization problem is one where we try to find the best solution from all given possible solution using a criteria. Means normal problems we solve the problems for a solution, but in optimizer problems we have to find the best solution out of given possible solutions. For example, you take one problem. Suppose a factory is making tables and chairs. That factory getting 50 rupees profit on one table and 30 rupees profit on a chair. In that factory, entire day there are only 18 hours of working hours in that factory. Now, as a factory owner, what is our problem is that here our main objective is we have to maximize the profits. Maximize the profit means you have to take a decision how many tables and how many chairs I have to make to get the profit. To take the decision, now this is comes under optimization problem, because here I am trying to maximize my objective of the problem. So how I can make profit by arranging sequence of making. So within this 18 hours, this is like a constraints on my problem. So every problem that has this kind of a nature, we can call them as optimized problem. Means we have a solutions, but we have to find the best solution out of possible solutions. So the optimized problem have four components: variables, objective functions, constraints, and feasible reason. Variables are of the problem. They decide. They give the. They help us in deciding the outputs. Suppose in my problem, what are the variables of my problem is like tables and chairs. Because my factory is making tables and chairs, these decide how many tables and how many chairs will give me a decision output. Next, objective function. My problem has an objective function, that is maximize. Means maximizing profit is my objective. Sometimes suppose I am purchasing something in a store. There my objective is to minimize the cost. Generally we bargain. Why we bargain? We try to minimize the cost, so that we try to purchase at lesser cost. There minimize is our objective. Suppose I am solving my problem. There I decide time. Time is a variable, and my objective is to minimize the time. Within the less time I have to complete my problem. That means these problems either they have a maximize character or a minimize character, like maximizing profits or minimizing costs. So that is second one. Means a problem first has a variable that tells what to decide. Second has an objective function, that whether we have to apply maximize or minimize. Third one, every problem comes up with some constraints. Constraints is nothing but rules on that problem. Suppose you take here, in my factory problem, what is the constraint is that factory works for only 18 hours. 18 hours means no matter how many tables and chairs you make, they have to make within those 18 hours only. So, and this is one constraint. So maximum number of tables taken, if a table takes 3 hours and chair takes 2 hours, maximum number of tables they can make is 9 tables, or 9 chairs, or 6 tables. So this is within this constraint only they have to get the maximum profit. So this kind of rules and limits are imposed on the problem, so that they can solve they have to find the best solution within satisfying within these constraints. And last one, every problem has some feasible reason. Means I have many solutions, but those solutions satisfy the constraints also. So these four are the components of a optimized problem: variable, objective function, constraints, and feasible reason. Now every problem we formulate within those four components, and we try to find the best solution for those problems. How we solve optimization problems? Solving optimization problems, we can apply normal classical search algorithms where like uninformed search or informed search algorithm like BFS, DFS, best first search, where we find the path from the initial state to the goal state. That is a normal problems we try to solve. But in optimization, we don't care for the path. Path is not that much important. We have to reach the goal state. So here, rather than searching for a path, we do we apply goal state. Like suppose here we apply local search algorithms to solve these optimization problems. Why we apply local search algorithms rather than classical search like informed and uninformed things? Here local search algorithms, what they take initial state and they explore all neighboring states and they improve those neighboring states so that they can reach the goal state at any time. That means every state has one objective value. If I either maximize or minimize, that state reaches that object value, then automatically we can solve the problem. Like suppose here I apply a local search algorithm for a n-queen problem. We all know that what is an n-queen problem. There are no two ministers, these queens should be on the same line, vertical line or horizontal line or diagonal line. So means there are no two queens should oppose each other. Now to solve this problem in our classical search like other algorithms, what we do, we draw one state space search and we starting from the initial state we find the path to the goal state. But in this local search algorithms, rather than exploring entire possible solutions, what we do, first I take one, this is the initial state, I take one neighbor state, means small change to this initial state, that means I move this queen. Now I check whether I am reaching my objective function, this solution is reaching the objective function or not. Then I make another move, so that a small change in two pawns, two queens, I am able to reach my goal state. Where here you see there are no two queens in the same line, vertical line, horizontal line, or means here I solve the problem within the less state space by initial state by making a small changes and creating a new neighboring states, and then checking whether no neighboring states taking me to the goal state or not. That is why local search algorithms are very highly preferred for solving these optimization problems. So we know, before going to solve these problems, let us just a small recap on these. Before that, let us. So here in optimization problems, as I told you, path versus state of. Here path is not important. Reaching the goal state is important, where every state can become a goal state, provided it with one objective function. That objective function may maximize the goal or minimize the goal state. So we have to identify whether it is a satisfaction problem or optimization problem. If it is just a small satisfaction problem, we can find the path. But if it is an optimization problem, the solution should be highly optimized. Means the best solution that will satisfy my objective function. Now, I use local search algorithms to solve these optimization problems. In next few sessions, I will discuss about these 4 algorithms of problems of optimization, like traveling salesman problem, job scheduling problem, graph coloring problem, and knapsack problem. So we solve these 4 problems using local search algorithms. By applying these algorithms, how we get the optimized solutions. So, but before that, let us just what are the algorithms, local search algorithms available to us? We have one first algorithm that I told discussed in previous sessions, hill climbing algorithm, that mimic the hill climber approach. Here, climber is nothing but an algorithm that trying to solve the solutions. And we have another problem, simulated annealing, where we it is inspired by the annealing process in metallurgy. And we have taboo search, where we we keep a list of previously visited cycles. And genetic algorithms, and local beam search algorithms. Generally, these 5 algorithms, they are used for solving our optimization problems. In upcoming sessions, we take the problem and we try to solve that problem using one of these local search algorithms, so that we will know how to formulate a problem, how to apply the problem, and how to get the solution to that problem. So other than now local search, there are other techniques also available to solve the optimization problems. Most famous technique that we use it for is gradient descent. Gradient descent is also like a analogy to our hill climbing, where solutions of the neighbor solutions of the problem are explored, and the optimum best possible solution is searched in those solutions. So gradient descent is generally applicable for optimization problems that involve neural networks. And evaluation algorithms technique, like our genetic algorithms, comes under this category, evaluation algorithms. So when you have multiple optimization problems with different maximization and minimization, then we go for opting this technique. Explores multiple solutions, unlike hill climbing. And we have simulated annealing technique is a local search algorithm. So when you have a combinatorial problems, so multiple problems, combination of the objective functions are there, we apply this simulating annealing. And we have another technique, Bayesian optimization, that uses probability technique to find the global models, RL optimization. So different techniques are available, but here we focus on solving our optimization problem only using local search, our simulated annealing, and hill climbing and genetic algorithms, so that we get some idea about the problems. You just we go through these slides, and while discussing about a problem, again we come across those things. Now, where these optimization problems are applied in real world applications. So in real world logistics, they use the optimization like a route optimization. Suppose what the best route to reach the goal. Like our delivery boys generally to deliver a item to the home, they go for this kind of option. What is the best route, shortest route to reach the house? Similarly, how to place warehouse storages, logistic. In finance, they portfolio manage optimization. Like, well, suppose people when they purchase the shares, how they invest and how they shares. But the maximization of the profits they take, those people they use this optimization technique. Healthcare scheduling patients and staffs means when multiple doctors and multiple patients are there, which patient require more attention from the doctor. Those are also optimized way they do it. ML algorithms, parameter tuning, they apply optimization technique. Engineering designing parameters at they apply optimization techniques. So optimization techniques has a lot of applications in real world. So we see how these optimization problems are solved in next class. Thank you.